السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. مع تحياتي لكم، أنا مستر حسام حسن، منصة البث المباشر، مع تحيات فريق المنصة لكم جميعا. إن شاء الله النهاردة الفاينل ريفيجن. نود إن احنا نكون في الترم ده حققنا الهدف المرجو إن احنا نحققه، ولو هناك تقصير فإن شاء الله يكون الأفضل القادم بإذن رب العالمين. طبعا احنا كان علينا، احنا عايزين نديكم كميه كبيره جدا من الحصص، ولكن احنا مرتبطين بجدول وانظمه وكلام من ده كله. فطبعا الكيمستري السنه دي محتاجه شغل كتير جدا، محتاجه دايما تدريبات كتيره. فطبعا احنا بنحاول نديكم الايدياز الاساس اللي بيسموها المين ايدياز للشغل بتاعنا. المهم عشان ما نطولش على بعض، ان شاء الله نبتدي النهارده الفاينل ريفيجن، اللي هو طبعا ده اللي هو last meeting for you. Now we start of the general exercise questions about oxidation number. How can you to calculate oxidation number? Now the oxidation number of nitrogen in ammonia gas is -3, while oxidation number in N2O3 is +3. What is the region or the scientific region of that? In this case, we have N nitrogen and ammonia gas NH3 is related with hydrogen. So the electronegativity of nitrogen is more than electronegativity of hydrogen. So nitrogen take negative and hydrogen take a positive sign now. In this case, ammonia's nitrogen, we find here in this example N-3, and hydrogen is positive. 1 times 3 equal to +3. Now, here in this case, N2O3 gas, nitrogen is less negativity, less than negative the oxygen, and calculations follow as nitrogen here is positive. Positive 6 divided to number 2, so the number of oxidation number equal to +3. So this is the main reasons for this changing of electronegativity and the differentiations between them and some compounds. Now we have the electronegativity make the importance factors for the changing of the oxidation number. So the oxidation number of chlorine in hydrogen chloride gas is -1, while oxidation number in hydrogen chloride acids HClO is +1. Why the same? We have the same regions. May here chlorine is higher than hydrogen in electronegativity, but here we find if you make calculation of this compounds, you find this -2 of oxygen and hydrogen is +1. So the calculation is chlorine is +1. Now in this case, hydrogen here in this example higher negative than oxygen, and calculation H +1 and chlorine it will be -1. In the next example, we find here chlorine, if you calculate it, -2, this is +1, so chlorine is +1, so it is the main region for that. Okay, what is the oxidation factor and reducing factor in the following equation? To know that, you must know very important things: the calculations of oxidation number of any atoms in its compounds, and you make subtracted between the product oxidation number and reaction or reactants oxidation number from the same atoms. Now we have this equation: sodium nitrite reacts with potassium permanganate and H2SO4 sulfuric acid. The result is sodium nitrate, potassium sulfate, manganese sulfate, and H2O. Now we have a way to calculate each atom in this equation. Now we compare the change F occur this change. Now we can to know what is the difference between the reactants and the products. Now we have NO2. Now we must calculate it firstly. Positive 1, okay. Oxygen is negative 2 times 2 equal to negative 4. So nitrogen is positive 3. Okay. Next, negative positive 1. This is oxidation number of potassium. Okay. Here in oxygen, negative 2 times 4 equal to negative 8. So negative 8 plus 1, so is negative 7. So the manganese equal to positive 7. H2SO4 positive 1 times 2 equal to positive 2. And sulfate is negative 2. Oxygen equal to negative 2 times 4 equal to negative 8. So the sulfur is positive 6. Now we complete all atoms in the reactants. We will transfer in the products to repeat these steps again. Sodium here, positive 1, and oxygen is negative 2 times 3 equal negative 6. So nitrogen is positive 5. We have the changing nitrogen here in the reactants equal to positive 3, and nitrogen here in the product is positive 5. Potassium positive 1 times 2 equal to positive 2. Now negative 2 times 4 equal to negative 8. The change between them, sulfur here equal to positive 6. We transfer here negative 2. This is SO4 polyatomic groups. Manganese equal to positive 2. If you want to know sulfur equal to positive 6, if you want to know the oxidation number, by using the summations between O and S, so equal to negative 2. Now we here in H2O, this is, you must study this changing between the atoms. Positive 1 is not changing. Positive 3 is converted into positive 5. Now here we here is changing. Okay, I will show you about a way to know which is oxidation and reduction and which is oxidation factors or oxidation agents or reducing agents by this way. Now you must subtract nitrogen positive 5 minus positive 3. The result is positive 2. So I conclude from these subtractions positive is oxidation. If the result is positive, is, we know from that is oxidation occur. Okay, positive 5 minus positive 3 equal to positive 2. Now the results is positive 2, so nitrogen ion lose 2 electrons. Okay, oxygen negative 2, 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 no change of oxygen. Potassium positive 1, positive 1. Now if you divided positive 2 and 2 equal to positive 1. Manganese positive 7, it's converted into manganese positive 2. Here the changing is positive 2 minus positive 7. The result is negative 5. So is manganese ion gain 5 electrons. 5 electrons. Now here we can to benefit from that. You have negative 5, I mean the electrons gain from here. Now we must changing that. Nitrogen is converts in N positive 5, now is positive 2, glues 2 electrons. Now in here in manganese, it converted from positive 7 into positive 2, so it's gain 5 electrons. This is oxidation occur, for it is a reduction occur. So the KMnO4 is oxidizing agent or oxidizing factor. NaNO2 is reducing agent or reducing factors. Now and oxidation is KMNO, oxidizing agent is KMNO4, and reducing A factors or agents is NaNO2. I mean, to write agent and factor, we have the same meaning. Now, if you ask, if I ask you arrange these compounds ascendingly, NaCl3, KClO4, KClO2 according to oxidation number of chlorine, and KO2, Na2O, H2O2 according to oxidation number of oxygen. Now we must calculate that. Now we have NaClO3 negative 2 times 3 equal to negative 6. Theirs is positive 1, so chlorine is positive 5. Now KClO4 negative positive 1, this is negative 2 times 4 equal to negative 8, so chlorine is positive 7. Now KClO2 negative, this is positive 1, oxygen equal to negative 2 times 2 equal to negative 4, so it's positive 3. So we have positive 5, positive 7, positive 3. This is smallest here is Cl positive 3. So this is the first KClO2. Now we have positive 5 in the next NaClO3 in NaClO3. We are here at the last KClO4, KClO4. Now this is arrangement of ascending arrangement of these compounds. Now we want to know this arrangement of these compounds according to oxidation number of oxygen. Now H2O2 oxygen here, but you must know hydrogen positive 1 times 2 equal to positive 2. This is negative 2 divided to 2, number 2 equal to negative 1. Now Na2O, we have Na positive 1 times 2 equal to positive 2, so is the oxygen is negative 2. Okay, now the transfer KO2, K positive 1, so oxygen is negative 1 divided to 2, so oxygen equal to negative half. Now you can to rearrange these compounds according to its oxidation number. Now KO2 less than H2O2 less than Na2O. We can transfer from this NaNO3 can oxidize by oxidizing agent because nitrogen, this nitrogen equal to positive 5, it is the highest oxidation number of nitrogen. Now if it needs very high energy to complete to crack completely main level, we have, because when calculating oxidation number of each atoms inside the compounds, we notice that the oxidation number of nitrogen is equal to positive 5 and is considered the highest oxidation state for it's because it is found in the fifth group. See its electron distribution n equal to 7 equal to the electronic configuration for this nitrogen equal to n 2s2 2b3 now equal to 5. We was be able to lose more than 5 electrons because it needs to break of all energy levels. Now we transfer in these sections. Now we have the following reaction doesn't represents an oxidation and reduction reaction. Okay, this reaction, when you study the oxidation number of each atom in this equation, you find phosphorus is positive 2. Okay, phosphorus here is positive 2. Nitrogen here is positive 5. Nitrogen here is positive 5. Oxygen is negative 2. Oxygen here is negative 2. Sodium is positive 1. Sodium is positive 1. Chlorine is negative 1. Chlorine is negative 1. So we conclude it's no changing here in this equations. Now this doesn't exchanging express this is not oxidation or reduction reaction. This is no change in the oxidation number. Now you must teach and you must study good the n equations to conclude is this equation oxidation redox reaction or not. Now, how many individual electrons are there in each? Okay, chromium positive 3. This is another sections for questions. Positive 3. Now you must make electronic configuration of chromium atom firstly, and you convert it into the structure of ionic structures. Now Cr positive 3. Now chromium equals to the electronic configuration. You must say copper plus 2 and iron plus 2. Now and nickel plus 2. Now we must solve these questions. Chromium atom is 3d5 4s1 or 4s1 3d5. When it loses electrons, it loses one electron from 4s firstly because it is the outermost energy level, and the other we have two electrons from d, so the electron configuration will be 3d3 only. Now number of single electrons is 3 electrons only. Okay, now copper in copper atom equal to 3d10 4s1. Copper plus 2 lose one electron from 4s and one electron from 3d10 will be 3d9. Okay, the number of single electron or unpaired electron in the orbitals equal to 1 electrons. Okay, we have another example. This example Fe atomic number equal 26. The electronic configuration equal to 3d6 4s2. So Fe plus 3 3d5. Number of single electrons equal to 5 electrons only. Number of is 5 electron only. Nickel 28 is atomic number. Now 3d8 4s2, nickel plus 2 equal to 3d8. Now number of single electrons is 2 electrons. Now this equation, I'm sorry, this is slide. The ion is major transition elements x positive 7. The number of electrons in the level M has equal the number of electrons in the level L. What is the number of single electrons in the atoms? Okay, now you must calculate the number of electrons in the level L and level M, so you will conclude the number of electrons in each other and the total electrons in the atoms. Okay, study that here. X positive 7, this is the level number 1 equal to 2 electron. Okay, level number 2 is 8 electron, and the level M equal to 8 electrons. Now this is X positive 7. Now we want to know the number of single of electrons here to know that, and this here is in sub levels and sub levels here. Okay, now this it will convert that this is the atomic, this is the ionic electronic configuration, the electronic configuration. Okay, it is returns to its atomic positions, returns the lost electrons. Okay, X here is lost 7 electrons from the outermost energy levels. You must return these electrons into the original state. As you see that we have here is 2 and 8 and 8 and yes and have 4s2. Now we have another 5 electrons, 3d5. This is the true electronic configuration or correct electronic configuration. To know the number of single electrons here equal to 5 electrons only and 3d5. The oxidation number of phosphorus in phosphine gas in pH 3 is negative 3, while its oxidation number in B2O5 equal to positive 5. Mention that, okay? Okay, mention that, okay, scientific reasons for this change. To know that, you must calculate BH3. Here, in this case, phosphine gas, B phosphorus, is higher negative than hydrogen, and when you calculate it, and this phosphorus equal to positive 1 times 3 equal to positive 3, so phosphorus equal to negative 3. Okay, now we have in this case P2O5. Phosphorus is less than negative from oxygen, because oxygen is higher than phosphorus in electronegativity. Now the calculation of the following P equal to negative positive 10 and oxygen equal to negative 10. This is the oxidation number of phosphorus equal to positive 5. Now, given the four quantum numbers of the last electrons in an atom of element X, n equal to 3, L equal to 0, Ml 0, Ms equal to positive half, and the electron structure of the elements Y is Nb3, illustrates by the equation the type of ionization of compounds YOH, XOH, and water. Okay, you must know which X and which Y to decide which is basic or acid. Now, it is the questions ask me for constant, giving I have four quantum numbers, and I have the electronic configuration at the same. Now, in this case of X equal to 3s1, how can you know that? 3, it is the number of principal quantum number 3, L equal to 0, so equal to L equal to 0, ML equal to 0. Okay, this is 3s1. 3s1 is the electronic configuration of sodium. Of the electron distributions was found that group 1a. This 1a is alkaline metals, and this alkaline metals is basic characteristics. So when it dissociated into X positive and OH negative, because sodium is a metal, and when its oxide will be a basic solution. Now when it ionized, it will ionize into metal positive and hydroxide negative. In this case of YNB3 of the electron distribution, and this in the case of a YNB3 of the electron distribution, it was found that's in group 5a. That is the nonmetal that's ionized as an acid. Okay, because it's in 3b. 3b is a nonmetals. Now we can conclude that nonmetal is acid, so it is dissociated into a YO negative plus hydrogen positive. This is hydrogen positive, indicates that from acid. Now we have this following equation. We want to study this equation and to know what is the oxidizing factors and reducing factors in these following equations. Now we have some ways to calculate the oxidation number of each atom in this compound. Okay, we have sodium equal to positive 1, oxygen negative 2 times 2 times 3 equal to negative 6, so nitrogen is positive 5. Fe positive 2, because sulfate, because sulfate equal to negative 2, so iron equal to positive 2. H2SO4, H equal to positive 1 times 2 equal to positive 2, so HCO4 is negative 2. Now Na is positive 1, 2 times 2 equal to positive 2, SO4 is negative 2. Now we have SO4 negative 2 times 3 equal to negative 6, so Fe equal to positive 6 divided 2 equal to positive 3. H2O that is here is -2, hydrogen is +2 divided 2 equal to +1. NO here is -2, nitrogen is +2. Now you can conclude the oxidizing agent and the reducing agent from this transferring. We have nitrogen is +5 transferred to and negative, I'm sorry, +2. The when you subtract +2 minus +5 equal to -3. Its electrons will gain. It gained 3 electrons from the other atoms. Now, if you changing that is reduction. Okay, NaNO3 reduction, and so it is oxidizing agent. We have FeSO4 converted from +2 into +3. Now, +3 is oxidation occur in this equation. Now we can to know the oxidizing agent and reducing agent from this equation. Okay, and generally in this oxidation, a oxidizing agent is NaNO3 and reducing agents equal to FeSO4. Now we finished this equation from studying the transferring of oxidation or reduction, and we benefit from this equation and have before the equation you make exercise in these equations to know the oxidizing agent or reducing agent. Now and these slides mention the scientific reason. I want to know the region of which one nitric acid HNO3 stronger than nitrous acid. HNO3 is stronger than, yes, true, because when you study that, you want the speed of dissociation of hydrogen in HNO3 is higher than HNO2, so we decide HNO3 is a strong acid and exactly stronger than HNO2. Now we have HNO3 and HNO2 to compare between them. HNO3 number of oxygen atoms bonded to nitrogen equal to number 2. But here number of oxygen atoms bonded to nitrogen is 1. Okay, the bonded and central nonmetals atoms for here equal to +5. So nitric acid is stronger than nitrous acids because it is the number of oxygen related or attached with hydrogen is more than number of oxygen attached in HNO3. So HNO2 is loose or less than HNO3 and so in its oxidation number. In this slide B, Fe2SO4 3 cannot be oxidized by oxidizing agent. If you study this compound, you find Fe as +3 and SO4 is -2. By using a number of valence of oxygen times 3 times -2 is equal to -6. Here iron is +6 divided to number 2, so equal to +3. Okay, I have two oxidation number of iron, +2 and +3, and +3 is more than +2. +3, 3D equal to 5, which is the most stable, but 3D2 is less stable than the other. Because when calculating the oxidation number of each atoms inside the compounds, we notice that the oxidation number of iron is equals to +3 and is considered the highest state of oxidation known as to know, and it because it's found in the 8th group. CH electronic configuration is 3d6, 4s2 3d6. It won't easily lose more than 3 electrons because it's most stable state. Okay, now in this next we find that The following reactions doesn't represent oxidation or reduction. This equation is titration or called neutralization action. Neutralization action express that we can consider that reaction between acid and base. Acid and base told me it is not redox reaction because it is no change in HA and its oxidation number of any atoms in the reactants and the products. Now we have many examples for how many individual I teach it before in this sections. This section this is completed as this cover and others, and know that for these electrons it's repeated, and now we know the number of electrons this equation is repeated is 4, and you can conclude that from these reactions. Arrange this following according to the atomic radius. You must make electronic configuration of each one. To know the position or location of each atom in the periodic table, and you can arrange this. Now you must make this table. These tables express that sodium 11, 3s1 electronic configuration, period 3, group 1a, okay, and we have chlorine 17 equal to 3s2, 3b5, and we have bromine 35 equal to 4s2, 4s2, 3d10, 4b5, and the other is 5s1. This is 1a, 7a, 7a, 1a. This is period 3 and 4 and 5. You can do rearrangements of according to what you want. This is electronic configuration leads to know the arrangements of these atoms in the periodic table according to S radius. Now cesium more than sodium, more than bromium, more than chloride. Now we must transfer another idea. Element X is the third main level, contains 15 electrons. What is the number of single electrons in its positive 3 ion, and what is the atomic number of the largest electronegativity element in its cycle? Its electronic configuration is 2, 8, 15, 2. How was distributed is known in this way by using electronic configuration by sublevel 2s2 and 3b6 and 3s2 and 3b 3d7, and we have 2 electrons in the last equal to 2 electrons. Okay, now you can calculating the oxidation number easily, and you can it is possible to make electron configuration of transferring from its places to another. Now it is impossible. Like this terms of distribution of the main, now we have electronic distribution of positive 3 ion will be like this in terms of distributions or distortions of the main levels, and will be lost first from the farthest major level and then the next. Okay, this electronic configuration 2 and 3, you must review that to find that electronic configuration. It's very easy to start that from the electronic configuration, but you must pay anything you must before to know any information for anything. Okay, number of single electrons in the ion positive 3 as shown in the level orbitals, we find here equal to 1s2, 2s2, 2b6, 3s2, 3b6, 3d8. Okay, 3d8. Now let's make electronic configuration. You find here is a transfer in the orbitals of the here 1, 2, 3, 4. 4 single electrons. And now we must know some things about oxidation number and about some things in the electronic configuration. Thank you for good listening, my dear, and we will meet you in the next term, inshallah. The meeting is over now, and we will see you later, God willing, my dear people. Assalamu alaikum wa rahmatullahi wa barakatuh.